Hello everyone, I am Manikanta. I am from CSD department of PUPSIT Vijayawada. Now I am here to discuss about data transformation technique in data science. First we ought to know what is data transformation. Data transformation is the process of converting raw data from its original format into a format that is more suitable for analyzing, visualization or machine learning. It is the process of converting data from one format or structure or representation into another format. Next, why we need to do data transformation? Data transformation is a crucial step in the data preprocessing pipeline for several reasons. First one, data preparation for analysis. It supports more analyzing techniques and algorithms to transform data into specific formats. To improve data quality. While doing transformation, we have to perform several cleaning and standardizing techniques in which we have to remove missing values and outliers and another data, insufficient data, which can significantly improve data quality. Next one, enabling analysis and modeling. It enables enhanced modeling performances. It enables enhanced model performances, reducing computational complexity. By reducing the dimensionality and removing the unnecessary data, we can reduce the computational complexity of the model. Next, strategies involved in data transformation. Data transformation contains many strategies, but I want to discuss these two techniques. First one, smoothing technique, and second one, normalization technique. First one, smoothing techniques. Smoothing techniques are used to reduce noise, uncover underlying patterns, and create a more simplified representation of the data. These smoothing techniques include three techniques, which are binning technique, regression technique, clustering technique. First one, binning technique. Binning technique, which includes two different types of implementations, but first one is binding technique by using bin means, which means first we have to arrange the data in ascending order, and we have to divide the each bin of particular size of the data and calculate the mean of the specified bin and replace the data of the bin with that mean. For example, here we have taken a bin 2233. Here the total sum 10, and we want to replace the data with mean by calculating the mean. Next one, binning technique by using bin boundaries. It is also, the first two steps are common: arranging the data in arrangement of data in ascending order and separate them as a bin. Here we don't want to calculate the mean. We want to check the boundaries of the number or data and transform the data into relevant data or nearest data element. This is called binning technique by using bin boundaries. Next one, linear regression technique. Linear regression technique, it is a smoothing technique, smoothing the data by plotting the data in graph and decreasing the distance between the regression line and point with the required value. Right, first we have data of something, data of data set. First we have to plot the data into a graph and we have to draw a line which is more significant. Now we want some points are fixed in that line, but all other points may deviate with some distance, so that we have to reduce the distance between the point and the line by adding some value or decreasing some value. We want to do this smoothing technique to make all the data as a consistent data. In this way, we can achieve data transformation with respect to smoothing techniques. Next one, clustering technique. It is also similar to regression technique, but little bit different. First we have to plot the data points in a graph, so that it may form groups of points. So that we have to group the data as a clusters. These groups we have called as clusters, and we have to reduce the distance and combine it with these clusters. Smoothing the data by plotting the data values in graph, which can be divided into two clusters in the given diagram, and the values are adjusted based on the groups. Next technique, normalization technique. Normalization is a data transformation technique used in data preprocessing to scale and standardize the features or variables of a dataset. The goal of this technique is to bring all features to a similar scale or range without distorting the underlying distribution of the data. This normalization technique supports three normalization techniques. First one, min-max normalization. Second one, Z-score normalization. Third one, decimal scaling normalization. First we have to discuss min-max normalization. Min-max normalization technique is used to scale numerical features within a specific range. Usually, min-max normalization we can perform this technique to transform the data within this user specified range, which means 0 to 1 or 11 to 20, anything. Min-max normalization ensures that the features have a consistent scale, making it easier for machine learning algorithms to learn patterns from the data. The given formula is used to transform the data in the min-max normalization. Here, Vi dash means the data we want to transform into that format, that is called Vi dash. Vi means the original data that we want to transform. Next, minus min of A, which means minimum value in the original dataset, into new max, which means the transformed data maximum number. New min, the transformed data minimum number. Max A, maximum number in the original data. Min A, minimum number in the original data, plus new min A, which means minimum number in the new dataset or transformed dataset. This is the formula. Now we have to discuss an example in this. Here the question is, suppose that the minimum and maximum values for the attribute income are 12,000 and 98,000 respectively. We would like to map income to the range 0 and 1, 0.01. Here they have given that maximum value in the original dataset 98,000, minimum value in the original dataset 12,000, and the maximum value in the transformed dataset is 1. Minimum value in the transformed dataset is 0. While performing this operation, we have 73,000 is the original data. We want to convert this data into Vi dash, transformed data, minus minimum of original data 12,000 by maximum of original data 98,000 minus minimum of original data 12,000 into new max minus new min, new max 1 minus new min 0 plus new min 0, which gives the answer 0.716. This is the transformed data. Here we have specified the range from 0 to 1, so we have result at 0.716. It is a transformed data. Next one, Z-score normalization. Z-score normalization used to scale features by subtracting the mean and dividing the standard deviation. This is also having some formula. Here Vi means same as usual. Vi means original data, Vi dash means transformed data, mean of A. We have to calculate the mean of the original data set and standard deviation of the original data set, and we have to perform this operation. Next, we have to discuss another problem in Z-score normalization. Here the question is, suppose the mean and standard deviation of the values for the attribute income. Here they have given mean and standard deviation. Mean 54,000 and standard deviation 16,000. With Z-score normalization, we have to calculate that value. So that here we have formula that Vi minus mean of A divided with standard deviation of A. Here Vi means 73,600 minus mean, they have given mean as 54,000 divided with standard deviation 16,000. Here we get the value as 1.225. By this way we have calculated the Z-score normalization. Z-score normalization. Next one, decimal scaling. Decimal scaling is a data transformation technique used in data processing to bring numerical values within a similar scale or range without distorting the underlying data distribution. The following formula is used to transform the data, which means Vi dash is equal to Vi divided with 10 power j, which means Vi means transformed data, j is equal to number of digits in the original data, which means suppose we have data as 32,000 in which the data consists of 5 digits, so j value becomes 5. If we perform this formula, we may get 0.32 like. So the data is transformed from 32,000 to 0.32, which means 0 to 1. By this way we can perform data transformation techniques. Thank you for listening this video.